Hello everyone, this is Shivam Sharma from Mechanical Engineering Department, ABS Engineering College, Kasaragod. I'm here to explain the topic Flexible Manufacturing System. It is a very important topic in the syllabus NME 031, Computer Aided Manufacturing. So, as the name suggests, Flexible Manufacturing System, it is a system which produces a wide variety of projects because of its flexibility, and also it includes automated material handling system which makes it even more flexible to accommodate changes very easily. So I'll start by showing you a PPT and discuss the further about FMS in the PPT. So we start here. As you can see, FMS is an automated mid-volume, mid-variety central computer controlled manufacturing systems. It covers almost all the manufacturing activities such as machining, sheet metal working, welding fabrication, and assembly. There are mainly four physical components of FMS, and these components include NC machine tools for performing multiple functions and integrating in themselves the automated tool interchange capabilities. The second most important component of the FMS is automated material handling system. This system helps to move between the machine tools and the fixturing stations. It transfers the workpiece between different machine tools and different stations. When the job is in transfer process from the inventory to the machine tools, and after the manufacturing has been done from the machine tools to the warehouse. The third important system is a computer control, which controls the machine tools operations and also the automated material handling system, and also brings a cooperation between the two, so that the flexibility of the system increases and also the efficiency of the system increases. It has the another component which has equipment such as coordinate measuring machine and part washing device. Now we move on to the next slide, which discusses further about the components of FMS. There are two main components of FMS. First one is the physical subsystem, and the second one is the control subsystem. We first will discuss about the physical subsystem. Physical subsystem physical subsystem is basically physical appearance of the flexible manufacturing system and the infrastructure of the FMS. The second important component of physical subsystem is the storage retrieval system, consisting of a pallet stand at each workstation and other devices such as carousel used to store parts temporarily between the workstations or operation. Now, the material handling system consisting of powered vehicle, conveyors, automated guided vehicle are also a part of physical subsystem. Powered vehicle, conveyors, and automated guided vehicles are the most important part of this physical subsystem, as they are the part of material handling system. They transfer the parts between different machines and different stations. Basic feature of physical subsystem is numerical control machine tool, work holding and tooling concentration, material handling equipment, and inspection equipment. Now we further move on to the control subsystem. Control subsystem is basically the control part of the FMS, which controls all the uh, which are helpful in making this system efficient. Control, it consists of control hardware, which includes mini and microcomputers, programmable logic controllers, communication network, sensors, switching device, and many other peripheral devices such as printers, mass storage memory equipment. It is basically a control software, that is, it is a set of files and programs used to control the physical subsystem. Now, for example, as we know that automated guided vehicle transfers parts between different machines, but the control subsystem takes care of that physical subsystem by routing it between the different machines and also taking care that it does not get damaged or the parameters do not change while transfer of the devices. Now, the basic feature of control subsystem include work ordering process and part control system. This is very important, in which order our jobs are to be sent to the machines for manufacturing, machining, or different operations that are to be carried out upon the workpiece. Now, machine tool control system including inspection elements. As the machine tool works continuously on different workpiece, so there must be an inspection mechanism which assures that the machine is in right condition and the parameters are in controlled magnitude so that the manufacturing process can be done efficiently. Now, the third important feature of control subsystem is tool management and control system. Tool management means that different jobs are to be performed, different operations, and different operations are performed by different tools. So, tool management means to load and unload the tool from the tool pallet whenever required and to assure that the tool is in the right working condition. Fourth feature of control subsystem is traffic management and control system. Traffic management means the routing between the two workstations. For example, a guided vehicle is carrying a workpiece from one part to another part. But there's another route where another AGV is transferring some other part between the two other machines. There may be a chance that these two AGVs may collide. So traffic management means we must ensure that the two AGVs or the different AVGs which are working in FMS should not collide and the routing should be done so as to minimize the time of transfer between the machines. Fifth feature of control subsystem is quality control management system, then maintenance control system, management control system, and interfacing of these systems with central computer. The control subsystems can interconnect, makes a connection between the central computer and the machine tools. So it is the very important part of an FMS, and we can say that it is the brain of FMS. Now we move on to the next slide, which tells us about the different layouts of configuration in FMS. The first one is inline layout, then loop layout, third one is ladder layout, fourth one is open field layout, and fifth one is robot centered cell. We'll discuss one by one. So first we move on to inline layout. Inline layout is suited best for producing a variety of parts. In inline layout, all the machines are set up in a series. In second, loop layout, parts can skip stations for flexibility, used for larger part sizes, and best for long process times. It means when we work on larger part sizes, there are a number of operations that are to be performed on them. And also these operations take a longer time than usual because of their size. So to improve the flexibility and to save time, we can skip certain stations and the multiple operations can be performed on single station. So loop layout helps in getting these objectives attained. Now, third one is ladder layout. Parts can be sent to any machine in any sequence, parts not limited to particular part families. It means in ladder layout, the machines are arranged in form of a ladder, like step by step, but the sequence is not necessarily to be followed. The parts can be sent to any machine at any time based on the requirement. Last one is open field layout, in which it is the most flexible FMS layout. Sorry, it is the most complex FMS layout and includes several support stations. Because of its complexity, it includes many support stations, which helps in ensuring that the process is carried out smoothly without any problems. Now I'll discuss about inline flow. The machine and material handling are arranged in a straight line. This means the machine moves from one workstation to the next in a well-defined sequence. In its simplest form, the machine passes from one workstation to the next in a well-defined sequence, with work always happening in one direction and no backflow. Care is taken that the workpiece always flow in a single direction. That means if n number of operations are to be performed on a particular machine, then the job will not move on to the next machine unless all the operations are performed, as no backflow is allowed. If the machine skips any operation or the operation is skipped due to any of the reasons and the job moves on to the next machine, then it will not be possible for the manufacturers to get it back to the machine. So it will cause wastage of material and also the workpiece will be get damaged. So In inline flow, the work piece always moves in a single direction. For inline system requiring greater routing flexibility, a linear transfer system that permits movement in two directions can be installed. So to overcome the problem that we discussed, a system can be a linear transfer system can be implemented in this type of inline flow so that it allows two direction flow. It will help in increasing the flexibility of this setup, and also if operation cannot be performed at a particular time, we can move the job back to the machine and perform that operation later. It will save time and cost. Now you can see the FMS inline configuration here in this line. Now we can see the inline flow. Straight line flow, well-defined processing sequence similar for all work units. Workflow is from left to right through the same workstations. No secondary handling system for figure A. Now, as you can see in figure A, there are a number of machines which are arranged in a line. There's a one starting area where work parts are loaded, and then at the end there's a unloading area where completed parts are taken off from the material handling system. In this, there is no secondary material handling system. But in figure B, there is a material handling system which is installed at each workstation, which enables the flow of products in two directions. It is similar that the start parts, the starting area, that means the loading area, and the unloading area in this type of flow is same. The workpiece starts at point A, and the completed parts return back to the point B and unloaded. Now we move on to the next configuration, which is loop layout. In this, one directional flow is possible, but variations in processing sequence possible for different part types. Now, secondary material handling system at each workstation. There are two kinds. First one, as you can see in the figure, is elliptical, and the second one is the rectangular circulation. In this also, the secondary material handling system is installed at each workstation. The loading and unloading area, that means starting and completing portions for the jobs, are the same. It increases the flexibility of the system, as if one of the workstation is skipped or we need to perform an operation after a certain operation has already been performed on the workpiece, so that we can move the workpiece again in the same path. It will complete all the processes, and then again we can move the part to the area. It is more flexible than machine. Next, we move on to the ladder layout. In this, the machine tools are arranged in a form of ladder. Ladder layout consists of a loop with runs between straight sections of the loop on which workstations are located. The direction of the workflow is in both the directions. It allows the workflow in many directions. So this system is more flexible, and the sequence of operations is not to be strictly followed. We can send the workpiece to any of the workstations depending upon the need or the freedom of that workstation. For example, if the workstation is busy working on another workstation, so we can send another job meanwhile to the next workstation. This will complete the process in a faster way, and also it will save our time and cost related to the manufacturings. Last one is the FMS open field layout, in which multiple loops and ladders which are suitable for large part families are used. Now you can see there are multiple workstations, and they are arranged in the ladder format, also consisting of different loops, so that we can see that it is a combination of loop and ladder layout, which further increases the flexibility. There's a starting area where parts are loaded onto the manufacturing system, and then when the part comes out after following all the loops and ladders depending upon the requirement that are to be done on the job, it again comes to the same place, and the completed parts are unloaded. in the same area. Configuration of FMS layouts. Now we move on to the advantages of FMS. So as we discussed, we must have already understood that FMS has a large number of advantages. A few of them are: it produces a variety of items under one roof. That means it increases the variety of products which can be sold in the market, and rate, hence bringing the more company. Efficiency, obviously, when the production is increased and the time and cost are reduced, the efficiency will increase. It improves product routing, as the central computer is used for traffic management, as we saw in the control subsystem. So it means the product routing will improve. The product quality will be the result of the above advantages as obtained from the FMS. It also reduces the setup and queue times. It reduces the time for product completion and utilize human workers for better activities. Now, the last topic of FMS is disadvantages of FMS. First disadvantage of FMS is limited ability to adapt to changes in product or product mix. As you can see, it has a limited ability to adapt to changes. For example, a manufacturing system is made, and this system is completely automated, controlled, and the fixtures and the pallets are also pre-designed. So this has the limited ability to adapt to changes. Substantial pre-planning activity is required, as this process requires a lot of investment initially. So substantial pre-planning is very much essential. If the substantial pre-planning is not done, it may incur losses to the company. It is very expensive. It includes all the computer systems. The system is completely automated, so it is very expensive. And sophisticated manufacturing systems. It is a very sophisticated manufacturing systems, so it requires a lot of care, and the control should be very well organized. So, guys, this is about. So, guys, this was about FMS, and now if you have any queries regarding this, you can contact me always. So thank you. Bye bye.